Hello everyone. So welcome to this course on large language models for beginners. Through this course, we'll try to understand large language models in a high level way. We'll not go into gory mathematical details, but we'll try to make sure that everyone who watches this course is able to understand how a large language model works and what are the basic abstractions and basic hidden details through which we get the outputs from common large language models like GPT, BERT, Llama, and so on, right? We're also going to be doing a lot of practical stuff, exploring different things we can do with LLMs, how we can improve the responses, and so on. So, with that, let's begin. So, in this first session, we'll try to understand what is the need for such large language models and what type of data is the large language model dealing with, right? So, in general, if you have seen some basic machine learning, deep learning, or in general, not even that, if you've just understood what data is, data looks something like this, right? So, suppose you have a typical Excel sheet where you have the name, where you have the age and a mark. So this is simply a classroom Excel sheet. So I'll have the first name as Alex, right? He's 20 years old and he scored 100 out of 100 marks. Then the second name is Gary, right? He is 21 years old. He scored 95 marks. So this is basically how we generally see data, right? So whenever we see data like this, what happens is the attributes that are there, the name, age, and marks, these are the basic variables of the data, right? Every data point has these variables. So these are called the variables. Right? And based on these variables, we can create multiple data points like this, where we give some value to the name, some value to the age, some value to the marks, and so on. Right? I can even create a new custom data point. Say Mary is the new one. Okay, and she is 19 years old and she scored 87.5 marks. Right? So in this way, I can create all my data points, which are very structured. So this is very well structured. There is a fixed layout of the information, and using this layout and these values, we can use some models, some machine learning, some neural networks, some advanced techniques to analyze this data. Right? Now what happens is, in the real world, how do we communicate? Data science is all the story of a communication, right? We have to basically communicate information through some data, get some information back on that. That is how the cycle of data science works, right? So when we communicate, what we do is, we don't communicate like this. We don't give information in tables and Excel sheets. We communicate using a language, right? Where basically we speak a lot of words, sentences, characters, and so on, right? That is basically the units of a language through which we are able to communicate. So that is where real world data that you will see, which is used for these communication purposes, which is used for communicating tasks to get the results and so on, for making interactions and so on, the data is in form of language, right? It is in form of language. Now what is a language? You know, the language is nothing but it is a sequence of words, right? Sequence of words will form sentences, and sequence of sentences is going to give us a language. So basically, the data that we are dealing with in such models is called sequence data or language data. How does it look like? A common sequence. This is a common sequence, right? A boy sat on a chair, right? This is the sequence data. Then a girl is new to this school. Okay, or we can say the girl is new to the school, right? So these are sequences. Now what is the difference between data like this and data like this? The main difference is that when we talk about this data, which is basically in forms of variables and attributes, this data is structured. Okay, there is a fixed structure, that is every data point will have three attributes: name, age, and marks. But when we are talking about data of this format, the language data or the sequence data, the data is not structured. So there is no structure here. Okay, because if I want to give a sentence can be this long. This has 6 words, this one has 7 words. I can even have a sentence of 2 words, right? A boy. This is also a sentence, right? This is also a sequence data, right? I can even have a paragraph as my sequence. So it can be anything. While I'm communicating a task, I can have a small task, I can have a very big task, I can have a medium level task, and so on. So that depends on what type of task I want to do, right? So that is how the length of the sequence data is very different. It is not structured, it is an unstructured data. And that is why processing this data requires different techniques from processing this type of a data, right? Another important factor is, whenever we are dealing with sequence data, let's take one small example. A boy is here, right? This is a simple example we are taking. Sequence data is always divided into time steps. Okay, time steps. So what is time step? Basically, I'll call this as time step 1, I'll call this a time step 2, time step 3, and time step 4. Now what is the basic meaning of this time step? The time step simply means there is a relation. There is a relation between all the words. The relation is, before time step 2, I have time step 1. Before time step 3, I have time step 1 and time step 2. And before time step 4, I have time step 3, I have time step 2, and I have time step 1. That means this word boy is seeing this word a before it. Right? Similarly, after I enter the two words a boy, then only I am seeing this word is. That means this has seen this and this has seen this. And similarly, this word has seen all the sentence before this. Right? Now suppose I enter this data in this format, a here boy is. Then this meaning goes. Okay, I wanted to say a boy is here, a here boy. This is no meaning for this, right? So I cannot exchange these time steps. These time steps and the sequential information is fixed. That is why this is a fixed sequence. I have a sequence which is going on like this. Okay, this is how we basically make a sequence. The direction is fixed. We are writing a fixed direction from left to right, or if some language is writing from right to left, you can even do that. But you cannot jumble them up. There is a fixed direction to the language, right? And that is why when we are dealing with sequence data, we have to make sure that the data set is sequential, right? It has a fixed direction and all the values in the data set are time stepped. Right? Time steps simply mean the first word, the second word, the third word, and so on. So those mathematically we call them time steps. So you will understand later on why is that so. But right now you can just memorize it that these are called time steps. Right? Similarly here, if you want to write the time step, this is T1, T2, and so on, and this is whatever Tn. Okay, for n words. So this is I think 7. So this is going to be T7. Right? So this is how we can time step sequence data. So just to conclude, the final words on sequence data. Sequence data is basically the data which we use to communicate. Right? This is what we understood. And this is basically in language. It can be in any language. Right now for this course we'll use English, but it can be in any language as well. Right? The second thing is this data is unstructured. There is no fixed schema, no fixed attributes that this data has. It can be any length, any sentence about any topic and so on. Right? And finally, this data is sequential. That means there are orders, okay, and these orders are maintained through time steps. Okay, so this is the three major attributes through which we can define a data as sequence data. This was very important. You need to understand what the data is. Once we have understood this data, we'll now understand how we can actually build systems and build models that can actually process this data and give us back output sequence data as well. So basically what we want is, we want some input, right? Input is going to be some sequence data. I'll call it ST. I'll put it into some system, which is basically the LLM, the large language model, which we are going to deal with, like GPT and BERT and so on. And we will get an output. Okay, this output is also going to be some sequence data. Input might be a task, the output will be the response of that task, and this model is going to process the sequence data and give me back the responses as well in sequence data. Right? That's the idea that we want to work with in this course. In the next session, we'll try to understand what the basic structure of a large language model is and how a large language model operates. Thank you.